So they want us to tell me what a reasonable rational equation would be for this function. Well, first of all, I've got right here a positive 1. At positive 1 and 5, and positive 5, that means that in the numerator I'm going to have x minus 1
and x minus 5.
And x minus 5. And then in the denominator, because this is at negative 2 and at positive 3, I'm going to have an x plus 2 and an x minus 3. So those things I know I'm going to have. And then this horizontal asymptote being at positive 2 means that the degrees of the top and bottom are the same.
Yes.
They have to be the same, which they are, because I'm going to have an x squared on the top and x squared on the bottom. And I'm going to have leading coefficients have to be 2 over 1 or something similar to that. And so
why is 2 on the top?
Well, because the leading coefficients are going to be 2x squared all over x squared, and then it's 2 over 1, and that's why it'll work.
Yeah.
So that seems like that would work out. You always have to kind of check and make sure, maybe if you can graph it or plug in a couple test points.
Yeah, I'm right.
You can plug in a couple test points, but that seems to be correct.
The 3?
So we're not quite done
cube?
yet, though, because remember the rules. When a 0 goes through, it has to have a leading. It has to be. Let's see.
Whatever works.
When you plug in some of these points, you'll realize though that this graph right here, this graph would be going like this, which my graph is not doing that. So I need to come up with some trick to make that happen. And long story short, I'm going to make this cubed so that it can't be squared because I want it to pass through, and the cube means it passes through the 0. Leave this as a 1, and I'm going to make both of these squared, and that's going to, when I plug in the numbers, when I plug in numbers between negative 2 and positive 1, it's going to give me a positive number when I plug those numbers in there. When I plug in numbers between positive 1 and positive 3, it's going to give me a negative number down there, and so that works. Wish I could tell you a better reason why, but that's just how it happens. I also needed to make these both squared because I wanted to keep these positive on the bottom. I want those, that will ensure that these both become positive numbers when I square those. And so now the numerator, all I have to worry about is I need one of these to be positive and one of them to be negative, so that this becomes negative for this section right here. And the numbers between 1 and 3, this is negative and this is positive. That's how I knew that that was going to be a negative number down there. And the numbers between negative 2 and positive 1, this now is negative, and this here is positive, so I know that I'm sorry, they're both negative, and a negative times a negative is a positive, and that's why that became a positive. So that's why that's basically one way to do that problem. I needed to make sure that that the powers up here were odd, because they needed to go through those zeros. And remember, if they're even, they would bounce off. And the bottoms I could have kept. It didn't matter. I made them both even to ensure that the degrees down here were both positive. The signs were both positive down there. And that's how I did that problem.